All right, everybody, welcome back to the show today. We are diving deep into AI and construction.
Ooh, fun.
Yeah, it's going to be a good one. We're looking at how large language models, or LLMs, are tackling a really, really hard problem,
Yeah.
which is scheduling these massive, complex projects.
Yeah, like semiconductor fabs.
Exactly. That's what we are looking at.
That's wild.
We're going to be looking at a research paper called CONSTRUCTA, automating commercial construction schedules in fabrication facilities with large language models.
Catchy title.
Yeah, it is a catchy title.
Easy to remember.
So construction scheduling, I mean, you've got to know a lot about this.
No, you're not. I mean, it is a beast.
Yeah.
So dynamic, so many moving parts.
Yeah.
Full of interdependencies, constantly changing things. Yeah.
And you need that human touch, right?
Exactly. You need expert judgment to make those really tough calls, and that makes it really hard for traditional software to handle.
And so that's where LLMs come in, right? That's
Yeah.
what we are looking at today.
At first glance, you might think LLMs are kind of a weird fit
Yeah.
for this problem,
Too much in the physical world.
Yeah, it's so grounded in the physical world. But this research shows they might be perfect for the job.
Yeah.
It's exciting.
They really might be. So how are LLMs uniquely suited to kind of tackle this challenge? What is it about LLMs that makes them good at this?
Well, it all comes down to their ability to process and understand massive amounts of information.
Okay.
Just like a seasoned construction manager,
Yeah.
would draw upon years and years of experience.
Okay, so they've got this kind of deep well of information that they can pull on.
Exactly, and that's what allows them to manage all the complexity of construction scheduling.
Okay, so let's break down this CONSTRUCTA framework.
Okay.
The paper talks about 3 core components.
Yep.
And the first one is static RAG.
Okay, so think of static RAG,
Okay.
like giving the LLM a construction encyclopedia,
Okay.
complete with all the jargon,
Mm-hmm.
the building codes, safety regulations, all that stuff.
So it's got the basics.
It's got the basics. This foundational knowledge lets the LLM speak the language of construction.
Okay, so it's not just understanding the words, it's understanding the context.
Exactly. It's all about understanding how those words are used in the construction industry.
That's cool.
And that brings us to the next component,
Okay.
knowledge arc.
What does that one do?
This is where it gets even more interesting.
Oh, yeah.
So knowledge arc lets the LLM act like a skilled architect,
Okay.
pulling in specific information that's relevant to the task at hand.
Mm-hmm.
So blueprints, material specs,
Mm-hmm.
real-time updates from the site.
So it's getting a live feed of everything.
Exactly. The LLM analyzes all of it.
So it's like thinking critically.
It's learning to apply its knowledge to specific scenarios, just like a human expert.
That is really cool.
It is. And this dynamic information retrieval is a huge step forward in making LLMs practical for real-world construction.
Especially because things are constantly changing.
Exactly where things are always in flux.
Okay, so the LLM is getting smarter by the minute, but I'm guessing there's still a need for human oversight.
Oh, absolutely, especially in construction,
Yeah.
where experience and intuition are so important.
Yeah, you can't build a building without that.
Exactly.
Yeah.
You can't, and that's where the third component comes in, construction RLHF.
Okay.
This is all about integrating feedback from, experienced architects, project managers,
Okay.
training the LLM to make better decisions.
To fine-tune it.
Exactly, to fine-tune its decisions and avoid those potential pitfalls.
So it's like an AI apprentice learning from the masters?
That's a great way to put it. It's not about replacing human expertise.
Okay.
It's about refining it.
So they give an example of this training process in the paper.
They do. Imagine an LLM, generating a schedule that has concrete pouring
Uh-huh.
happening before the foundation is set.
Big problem.
Yeah, a human expert would flag that
Yeah.
immediately, and the LLM would learn from that mistake.
Okay.
It would adjust its algorithm to prevent that from happening again.
So it's a continuous feedback loop.
It is. It's making the LLM more and more reliable over time.
Very cool. I'm really starting to see the potential here.
Yeah.
But how well does this actually translate to real-world results?
Well, researchers put CONSTRUCTA to the test using a real data set of semiconductor fab activities.
Okay.
And the results are pretty amazing.
Give me the highlights. What kind of improvements are we talking?
Okay, so they saw a 42.3% improvement in predicting missing values.
Wow.
Meaning the LLM got much better at filling in the gaps when project data was incomplete.
Okay, so that's a huge time saver.
Yeah, huge time saver right there. They also found a 79.1% improvement in dependency analysis.
What is dependency analysis?
So dependency analysis is all about understanding the relationships between tasks.
Okay.
You can't install electrical wiring before the walls are up.
Right.
The LLM needs to understand those dependencies to create a realistic schedule.
Right. So 79.1% improvement.
Yeah, that means the LLM is much better at figuring out what needs to happen.
Yeah. What order to do things.
Exactly. And they also saw a 28.9% improvement in overall automated planning,
Wow.
meaning the LLM generated much more efficient and realistic schedules compared to traditional methods.
Yeah, that's awesome.
It is. And they validated these results across different disciplines, experience levels, and project areas,
Wow.
showing just how adaptable this framework is.
Those are really impressive numbers. It sounds like Constructa is living up to its promise.
It really is.
But what's happening that allows it to achieve these results? What's going on under the hood?
One key factor is its ability to distill knowledge.
Okay.
Think of it like this. Imagine having to sift through mountains of paperwork to find that one crucial piece of information.
Yeah.
Constructa can do that automatically, identifying and prioritizing the most relevant information.
Okay.
So it's not just about processing information.
Mm-hmm.
It's about understanding what's most important in a given context.
So is that what they mean by context length reduction?
That's exactly what they mean. It's all about making the system more efficient by focusing on what matters.
Okay.
And this knowledge distillation is what allows Constructa to handle that massive amount of data involved in these projects.
Yeah, construction projects have so much data.
They do, without getting totally bogged down.
That's really cool. I'm wondering if this tech could be used in other industries that have complex processes.
Absolutely. And that's what we'll be looking at in the next part of our deep dive.
Okay.
We are going to explore the broader industry implications of Constructa and what it could mean for the future of construction as a whole.
Awesome. I'm excited to hear about that.
Yeah, me too. It should be good.
We'll be right back after a short break. All right, so we've seen that Constructa can handle the complexities of construction scheduling, but let's talk about semiconductor fabs.
Oh, yeah?
I mean, those facilities are like something out of a sci-fi movie.
They really are. The level of precision required to manufacture those tiny chips,
It's insane.
it's mind-boggling.
Yeah.
And any delay in the construction process
Yeah.
can cost millions.
Yeah, time is money.
It really is.
Yeah.
That's why the potential of LLMs in this industry is so significant.
Because even a small hiccup can throw everything off.
Right, a small hiccup can have a ripple effect throughout the entire project.
Yeah, so how is Constructa being adapted to handle the unique challenges of building these fabs?
Well, remember that static RAG component we talked about?
Yeah, the construction encyclopedia.
Exactly. That's where the LLM gets its basic construction knowledge.
Yeah.
But in the case of fabs, that means feeding it information about clean room protocols, specialized equipment operation, the physics and chemistry of chip making.
So it's like giving the LLM a crash course in semiconductor manufacturing.
Exactly. On top of its construction expertise.
Right.
It needs that specialized knowledge to understand the unique constraints and dependencies involved in fab construction.
And what about knowledge rag?
Yeah.
The part that pulls in the real-time information.
Right. So think of it as giving the LLM a live feed of what's happening on the fab floor. Sensor readings from equipment, environmental monitoring, data progress, reports from different teams, potential disruptions like equipment malfunctions. The LLM is constantly analyzing all of that.
So it's not just sticking to a static plan, it's adapting.
It's adapting to changing circumstances on the fly.
That's really cool. Does the paper give any examples of how this dynamic scheduling works in practice?
Let's say a critical piece of equipment breaks down unexpectedly.
Okay.
The LLM would instantly recognize the impact on the schedule, analyze alternative options, and maybe even suggest reallocating resources to minimize the delay.
So it's like having an AI project manager who can think 10 steps ahead.
It really is. It's like having an AI project manager who can anticipate potential roadblocks.
But where do the human experts fit into all of this? I can't imagine you can build a semiconductor fab without skilled engineers and technicians.
Absolutely not.
Yeah.
And that's where construction RLHF comes in. Remember, that's where human experts provide feedback and guidance, making sure the LLM's decisions align with real-world conditions and their expertise.
So it's a collaboration, not a replacement.
Exactly. The LLM provides the computational power, and humans bring their experience, intuition, and problem-solving skills to the table.
Do they give any specific examples in the paper of how that collaboration works?
Yeah, they highlight how experienced engineers can use the LLM-generated schedules as a starting point, making adjustments based on their knowledge of the fab environment and any potential issues the LLM might have missed.
So the LLM can crunch the numbers, but you still need that human touch.
You need that human touch to account for all those unpredictable things that happen in construction.
So let's talk results.
Hmm.
Is there evidence that Constructa is actually making a difference in these fabs?
Well, widespread adoption is still in its early stages,
Okay.
but the companies that have implemented Constructa are reporting some significant benefits.
Okay, like what?
Reduced project lead times, better resource allocation, fewer costly delays.
So it's saving time and money.
Exactly. It's making a real impact on the bottom line.
But I'm guessing there are still challenges to overcome before this becomes mainstream.
You're right. One of the biggest hurdles is data integration. Semiconductor fabs generate an enormous amount of data from all sorts of sources, and making sure all that data is clean, properly formatted, and accessible to the LLM. That's a big task.
It's like trying to teach the LLM a new language.
It is. It needs to understand how to interpret the data coming from all these different systems. And then there's the ongoing challenge of keeping the LLM models up to date. The world of semiconductor manufacturing is always evolving. New technologies and processes are emerging all the time. The LLM needs to keep learning to stay effective.
So it's not a one-and-done solution.
Nope. It requires ongoing investment in data management, model training, and collaboration between AI experts and industry specialists.
It's a continuous process of refinement and improvement.
That's it.
This deep dive into semiconductor fabs has been fascinating. It's amazing to see how LLMs are being applied to such a complex and technologically advanced industry. But it also makes me think about the bigger picture. What does all of this mean for the construction workforce as a whole?
That's a great point, and it's something we'll be exploring in more depth in the final part of our deep dive. We'll be discussing the potential impact of LLMs on construction jobs, the skills that will be in high demand, and what the future might hold for human workers in an increasingly automated world.
I can't wait.
Yeah, it's going to be interesting.
We'll be right back after a short break. Okay, welcome back. We've talked about a lot of different stuff so far.
Yeah, we have.
From how Constructa works to how it can be used in those semiconductor fabs.
Yeah, really cool stuff.
But now let's talk about the elephant in the room.
Okay.
What does all this mean for the people working in construction?
Yeah, that's a big question.
I mean, we've already seen automation impacting other industries like manufacturing.
Right.
But LLMs are different, right?
They're
They're not just replacing manual labor. They could potentially automate some of those brain-heavy jobs.
Exactly. The tasks that we've always thought of as requiring human expertise.
Yeah, so architects, engineers, project managers, those kinds of jobs.
Yeah, it's natural to wonder if those jobs are at risk.
Right, and it's a valid concern.
It is.
But do you think it's fair to say that LLMs, at least for now,
Yeah.
are more like really advanced tools?
I think so.
Not necessarily replacements for people?
Yeah, I agree. LLMs are powerful, but they still rely on data algorithms and human input.
Right.
They don't have the intuition or creativity
Yeah.
or adaptability of humans, especially in a field like construction where things are always changing.
So maybe instead of being afraid of LLMs,
Yeah,
we should think of them as a way to help us do our jobs better.
exactly.
So we can focus on the things that humans are really good at,
like what?
like problem solving and being creative.
Yeah, I like that way of thinking about it. It's a much more positive outlook.
Imagine a world where architects can use LLMs to come up with all sorts of new designs.
Oh, yeah?
Or engineers can use AI to find potential problems before they even happen.
That would be amazing.
That would save so much time and money.
And headaches.
So what you're saying is that LLMs can help us work smarter, not harder.
Exactly. That's the goal.
So what advice would you give to someone who is working in construction right now, or maybe thinking about a career in construction?
I would say the most important thing is to never stop learning
Okay.
and focus on skills that work well with AI, not against it.
So things like critical thinking, problem solving, communication, collaboration.
All those things are going to be super important no matter how much technology changes.
It's about having a flexible mindset
Right.
and being able to adapt to new challenges.
The construction industry has always been about solving problems and coming up with new ideas.
Yeah.
LLMs will change how we work, but they won't get rid of those core skills.
Well, this has been a really interesting deep dive.
It has.
We started by talking about Constructa.
Mm-hmm.
Then we looked at how it could be used in those semiconductor fabs.
Yes.
And now we've come full circle back to the human side of things.
It's all connected.
LLMs have the potential to change construction in a big way.
They do.
But it's up to us to make sure that those changes are good for everyone.
Couldn't have said it better myself.
Yeah.
The future of construction is about humans and machines working together
Yeah.
to build a better industry for everyone.
Thanks for joining us on this journey. I hope you learned something new and maybe even got a little excited about the future of construction.
Me too.
And who knows, maybe next time we'll explore another cool way LLMs are being used in a different industry.
Ooh, that'd be fun.
Until then, keep those minds curious, and we'll see you on the next deep dive.